All right, good morning, everybody. So in a previous lecture, we were talking about regular expressions. And I forgot to tell you, or I forgot to complete the notebook, because at the end of the notebook, there's an example of using this very useful program called grep. And so I'm going to jump back to the regular expression notebook and complete that notebook. So there's a program called grep in Bash that turns out, in Unix, that turns out to be very useful. So because all data in Unix comes from files, it's often the case that you want to search a file for some piece of information. If the search that you want to do is relatively simple, then grep is very useful for this purpose. So grep stands for Global Regular Expression Print. And so it's one of these programs in Unix that uses regular expressions, and in this case it uses a regular expression to search a file. So it looks for all occurrences of this regular expression in a file. Grep's an older tool, and there are many flavors of regular expressions. So to use the flavor of regular expressions that I showed you in the notebook, you have to pass in an option. So that option is -E. So that uses what's called the extended POSIX regular expression syntax. If you don't include the -E, you get the simple regular expression syntax. So some of the things that I showed you how to do may not be available to you if you drop the -E. There's other flavors of regular expressions that you can specify as well. So the way they use grep is, well, the name of the program is called grep. You can give it some options. You then give it a regular expression. And then you give it a list of 0 or more files. And grep will search those files for any occurrence of that regular expression. If you don't give it any files, it will search standard input. Okay, so here's some examples of using grep. So remember, we're going to specify a regular expression, and we're going to use grep to search for all occurrences of that regular expression. So it searches for all lines that contain that regular expression. And so I'm going to show you what not to do first. So here I'm using ls to list the contents of my user bin directory. Right, so remember, that's the directory that contains many of the executable programs that I can run in my installation of Linux. I'm going to take the output of ls and I'm going to pipe it to grep. Right, so here grep is searching for, so that regular expression here is just zip. So remember, that regular expression means find any word or any line containing the word zip. Right, so it doesn't have to start with zip, it doesn't have to end with zip, zip just has to show up somewhere in the line. And so this will find all files in that, will list all files in that directory that have zip as part of their name. Right. This one will search, it's the same example, but this time the regular expression changes slightly. So remember, the caret in front means lines starting with. So this will find all files that start with the word zip. And then finally, zip $ means find all files or list all files that end with the word zip. And if you run that, it does exactly what you'd expect. Right? So it lists all the files that contain the word zip, and my version of grep happens to highlight the occurrences. Right? And so you get a bunch of them here. Then you get the files that start with zip, so you can check to make sure that all these files actually start with zip. And then you get all the files that end with zip. Right? And so there's an example of using grep. It's a bad example because you can do all of these without using grep. Right? So to find all the files that contain zip, you would just do ls or ls root user bin *zip*. Right? So here you can use a bash wildcard expansion or file name expansion for all of these. Right? All files that start with zip, well, that's easy too, right? ls root user bin start with zip, zip star, like that. Right? And all the ones that end with zip is equally doable without relying on a regular expression. So *zip, like that. Right, so yes, regular expressions are powerful, they're very handy. They normally shouldn't be the first tool you reach for when you're trying to solve a problem. If you can solve it without using the regular expression, you're probably better off not using the regular expression. Excuse me. Okay, how about some more complicated examples? So here I've got a Java program. It's just it's some old assignment, Sys124 assignment solution. And often when you're programming, you want to search your program for some occurrence, for an occurrence of something, right? It might be for a variable name. In this case, I want to look for all for loops. So the obvious way to do this is to look for any line that contains the word for, right? So that's a simple regular expression. It's just the word for, right? And if you do that, you get this output here, right? And you see, well, yes, that is indeed a for loop, right? The last four are indeed for loops, but here there's a comment that happens to contain the word for. If you don't want to include that line, you have to tune your regular expression to get rid of the false positives. So how can I tune this regular expression to not give me that line 121? There's a lot of ways you can do this, right? And so one way you can approach the problem is you can ask, well, what does a for loop look like in Java? Well, it's the word for, then there might be a space, and there might not be a space, right? There might be multiple spaces. There doesn't have to be a space, right? And then there has to be an opening round bracket. So you can write a regular expression that searches for 0 or more spaces, opening round bracket, right? So 4, right? 0 or more spaces. So it turns out in Java, it doesn't have to be just spaces. What's going on here? There we go. It can be any white space character. Right, so Java allows you to use spaces or tabs here. Searching for a new line doesn't work with grep because grep searches individual lines. So you can, I don't think there's any way to actually search for a new line and extend the regular expression. So here I'm going to look for star, so 0 or more spaces of some kind, right? Followed by a round bracket. Now, remember the round bracket in a regular expression indicates the start of a sub-expression. So I need a character class and put the round brackets inside the character class to correctly capture the round bracket, right? And when you do that, that indeed gets rid of the gets rid of the line containing the comment that has the word for in it. And so there's an example of searching a piece of software, a program for some piece of text. This turns out to be very useful, by the way. Here's another example of searching a piece of a program. In this case, we're going to search an HTML document, so a web document, right there. And I'm going to look for all of the anchors, so anything that you can click on inside this document. So if you don't know HTML, an anchor is anything that starts with an A inside of angled brackets, right? And so we can search for that regular expression there. Here I've got a space after it, so we're looking for anything that has an angled bracket, A space. Right? I have to quote this particular regular expression because I want to include the space. Right? And so there, oh, sorry. So assuming that file actually existed somewhere, it would actually search that file for all of the anchors in that web page. Right? One more example. So this one is slightly more sophisticated. So here, I happen to have a file on my computer in that directory called words. That's basically a list of English words. It's basically a dictionary, so it's an alphabetic list of English words. It's not all of the English words. It's just some fraction of the English words. So if you like to play crosswords and you like to cheat, you can easily write a regular expression to help you cheat. Right? So here I want to search for I want to look up in the dictionary for all words that start with anything, followed by AK, followed by anything ending with an S. So I'm looking for all 1, 2, 3, 4, 5, all 5-letter words where the second and third word are AK and the last word is an S, right? And you end up with that list there, which you can then try to plug into your crossword, and hopefully that saves you some work. Okay, so that's enough for the purposes of this course regarding regular expressions. If you want to learn more, there's lots of links at the bottom of this page that point you at some starting points where you can find out more about regular expressions, should you be so inclined. There's a quote here. This guy's named Jeff Atwood. He's a fairly well-known, or was a fairly well-known blogger. Sorry, I think he's still alive, but I'm not sure how relevant his blog is anymore. So he says, regular expressions are like a particularly spicy hot sauce to be used in moderation and with restraint only when appropriate. Right? So now that you know about regular expressions, don't try to use them as a hammer to try to solve every searching problem. It's not always the most appropriate tool. But when it's the appropriate tool, it turns out to be very powerful. Right? All right, so that's wraps up all of the notebooks except for one. And so we're on the last notebook now for Bash. We're on the functions notebook. Functions in Bash are strange. Well, the functions aren't strange. Well, they're a little bit weird. The way variables behave in a Bash function, in a Bash program is strange, as you will shortly see. Okay, so Bash does have functions. So function's just a reusable chunk of code that you can call by using a name, right? So you know this from 121 and 124. But the way that you pass information to a Bash function and the way that you get information back from a Bash function and how variables work when you have functions is very different than how it works compared to modern languages. Right? Okay, so how do you declare a function? I guess that's step one. So you can declare it in two different ways in Bash. You can either use the keyword function and then give it the name of the function, then the braces. Inside the braces is just the list of commands that define the function. Right. Alternatively, you can use a function name, double round brackets with nothing in between. Then the braces, and again the commands inside the body of the function. The first form is fine in Bash, so it always works in Bash. If you want to write it that way, it's fine. Many authorities will recommend you write it this way because the second way is more portable. So if you need to take your script and move it to a different shell language, the second form will probably work. Notice that in both forms, there's no parameters. Right? So in other words, there's never anything inside the round brackets here. There's never anything after the file name here. Right? So parameters are not explicitly listed in a Bash function. I think in the notebook, I exclusively use this form here. And I often forget and then switch to that form there. But anyway, they both work in Bash. The space here. There has to be white space after that brace. And there has to be white space somewhere else. Space or new line after the opening brace. And the new line before the closing brace are important, as it turns out, so they have to be there. If either is missing, then a syntax error occurs. Click on that link to go to shellcheck.net and see what happens if you forget one or both of the spaces that are required. Right. And so I guess here's an example here. So, right. So here's an example where I'm missing the new line here. And so it complains. You get a syntax error near expected token echo. And that's all the information that you get. Right. And then you also get another syntax error saying syntax error near the unexpected token closing brace. So the Bash error functions are not very helpful. Sorry, the Bash error messages are not very helpful. Again, so I did tell you about shell check in a previous lecture. I recommend you use shellcheck.net to test your scripts before you use them, or to help you debug them. It will catch many of the common Bash programming errors. Right. So let's get rid of that. See what happens. Okay, so it's happy now. The indentation is not significant here as far as Bash is concerned, but for the purposes of readability, you should indent. Here's another example of so you need the new line here as well. Right? If you run this, I'm pretty sure, yeah, it barfs. Right? Again, for the missing new line on the closing before the closing brace. Okay, so here's a little function called greet. Right? It does nothing but print hello. Right? How do you call the function? Well, somewhere in your script you can just write greet, and that calls the function. Right? So if you run that script, you get 0 and then hello. Why do you get the 0? Sorry, I have to go to my. It's probably because I edited the script at some point. This is functions, and so this is, so what am I doing? Oh yeah, so I did edit the script. I am printing out the, here we go. Okay, so this is useful. Why is there a, okay, so do I have the, no, I don't have there. All right, so that number there is the number of arguments that were passed to the function, right? So when you call the function here, if you want to pass arguments to the function, it's exactly like calling a command, Right? You write the name of the function, then there's a space, and then you pass in your arguments, each argument separated by spaces. Right? If your arguments have special characters in them, just quote the arguments and pass them to the function. Remember, everything in Bash is a string. And so your function will end up getting however many arguments you pass to it. Right? Okay, so how does it know what the number of arguments are? So somewhat confusingly, Bash recycles the $number, $1, $2, $3, and $0 positional parameters. Right. So inside of a function, you can also use $number to get the number of arguments passed to a function. Right. So I'm using it right here. Right. If you want to get the arguments passed to the function, these should be called arg, not param. But anyway, so they're $1, $2, $3, and so on. Right. Just like $1 for a command line argument would be the first command line argument passed to a script. Right. Here, $1 is the first argument passed to the function. Right. $number is the number of arguments passed to the function. Right. And here we're going to call it with a bunch of different arguments. So test with no arguments, with 1, with 2, with 3, and with 4. Right. Notice that when you pass it 4, the script never actually uses the fourth argument. Right. Also notice that if you pass it 0, 1, or 2, it looks like there are not enough arguments passed to the function. Well, let's see what happens when we run it. Okay, so let's start with 0. Right. So it tells you there are 0 arguments passed to the function. Right. And it tells you what the parameters are. Right. So the parameters are all empty. So again, no error. Right. If you try to access the value of param1, param2, and param3 here, right, and you didn't pass in any arguments, these just all become the empty string. Right. No error. Right. Exactly the same way that your script behaves. Right. You pass one argument to a function, right? So it gets the a in this case. Why does it get the a? Oh yeah. So here we're calling the function here. I'm sorry. And so we pass in the a, right? So param1 is a. Param2 and param3 are both the empty string, right? The number of arguments 1. Right? And so on, and so on, and so on. So when you have 4 arguments passed to the script, it's not an error to call it with 4 arguments, right? But the script never uses the 4th argument. Notice here, we also print out the number of arguments that were actually passed to the script itself. Right? So here are the number of arguments passed to the function. When I called the script, I passed in no arguments. Right? And so the script knows that no arguments were passed to the script. So the point of all of this is that $number, here, $n right here, right there. So $number, when you call the script, it's the number of arguments passed to the script. Once you call a function, $number becomes the number of arguments passed to the function. When you get out of the function, though, and go back to the main script, $number is again the number of arguments passed to the script. Right. So similarly, $1, $2, and $3, when you pass them to the script, those are the command line arguments passed to the script. Inside of a function, they are the arguments passed to the function. When the function is done, $1, $2, and $3 back in the main script are again the command line arguments passed to the script. Right. So the meaning of $number and $1, $2, $3 is context dependent. Right. Inside the main script itself, they refer to the command line arguments. Inside the function, they refer to the arguments passed to the function. Okay, so how do you return a value from a function? So this is the weird part. So a function looks a lot like a command in Bash. Right? How do commands generate output? They print something. Right? So if your function wants to return something, one way to do that is to have the function print something. Strange, but that's the way it works. There's another way. There's something else, though, that happens when you call a command. Right? So when you run a command in Bash, you get an exit status. Right? Similarly, when you call a function in Bash, you get an exit status. Right? If the function executes without any errors and does not specifically set exit or call exit or return, you end up getting a value of 0 as the exit status for the function. right? And so functions and commands are more or less the exact same thing in bash, more or less. And so what that means is if you want a function to return a value, you can either set an exit status or you can print something out. But there is no other way to return something from a function, which is weird, but that's the way it works in bash. Right? So the return keyword in bash doesn't actually return doesn't do what you want it to do. Right? So it causes the function to stop executing and it sets the exit status, but there's no way to write return some string, right? Which in many cases would be what you wanted. Right? If you want a string back from the function, you have to print the string and you have to capture the output of the function. So here's an example of a function that sets the exit status using return. So some func, right? But what is this doing? So it's gonna it's gonna get a random number, right? It's going to check if the random number is evenly divisible by 2, right? If it is, it's gonna return a 0. Otherwise, it's gonna return a 1, right? How do you get the return value? Well, it's the exit status of the function that's stored in $question mark, right? So here, it looks like our first random number was even. Sorry. Our second random, there we go. Our third random number was odd, right? Our next random number was even, another one's even, and so on and so on and so forth, right? So you can get the, one way to return a value is to look at the exit status of the function. You set the exit status using return, right? You cannot get a string back from this particular, using this particular technique though. Similarly, the number of exit statuses is limited. Somewhere between 0 and 128, I think, although I'm not exactly sure what the real number is. So you're also limited on the value that you can actually return here. Okay, so if you want to return something else, like a string, then you must have the function print the string, and you must capture the output from the function. How do you capture the output? Well, function's like a command, so you use a command substitution. So here's max2. Right, max2 expects 2 arguments, right? So it's going to use $1 and $2 for its arguments, and it's going to print the larger of the 2 arguments, right? So it does nothing but print either $1 or $2, right? Whichever is larger. We've got another function called isInt, right? IsInt uses the exit status technique to determine whether or not the argument passed to the function is an integer, right? So it sets the exit status to 0 if the argument is an integer, sets the exit status to 1 if it's not an integer. And now we have the rest of the script, right? So if the number of arguments passed to the script is 0, we exit, in this case with an exit status of 1. Right? Okay, we now want to know is the first argument to the script an integer? So I can call the function like that. Right? Remember, the exit status of a function can be used as a condition for a command. The exit status of a function or a command is the condition for an if statement. So there's my function in this case. Right? We're going to pass in the command line argument. Right? So if there is only one command line argument and it's an integer, then I know the maximum value of all my command line arguments is just the value. Right? So it's 1. If it's not an integer, it doesn't make sense to compute the maximum of the command line arguments. So we exit with 2. Okay, I have to show you what shift does in just a second. If the number of command line arguments is greater than 0, right? I'm going to look at all the command line arguments, right? So if the first command line argument is an integer, right? Then the largest command line argument I've seen so far is the maximum of high and 1 and the first command line argument. Right? So I'm using high to remember what is the current largest value that I've seen so far of the command line arguments. Okay, so this looks like it always compares the current high to the first command line argument. Right? But that's not actually what it's doing, because later on there's this command called shift. So what shift does is that it shifts all the command line arguments 1 position to the left. Right? So whatever was the first command line argument disappears, and the second command line argument becomes the first command line argument now. Right? So when you shift, the value of $1 becomes the original second command line argument. Right? When you shift again, the value of $1 becomes the original third command line argument. You shift again, the value of $1 becomes the fourth command line argument, and so on and so on and so forth. So using a while loop like that, and shifting at the end of the while loop, lets you process all of the command line arguments one at a time, starting with the first, right? You always use $1 inside, right? Because you're going to shift the command line arguments over, right? And so there is one way to process all of the command line arguments using a while loop and shift. Finally, this prints out the high, right? So it processes all the command line arguments. So in other words, it processes the 1, the 5, the 7, and the 4, remembering what is the largest value it's seen so far, right? And it prints out, in this case, the 7. Right? And so here you've got a function that uses the exit status, or returns information using the exit status. And here you have another function that prints the result. I guess I have to, where's max2? Here it is. So notice how I get the result from max2, right? Max2 prints its result, right? Prints the larger of the two values. To capture that output, you use a command substitution. Right? So $round bracket, treat max2 like it was a command, and I want the output of the command. Right? So you capture it with a command substitution. And that's how you get a return value from a function. Sorry, that's the second way to get a return value from a function. Print the result, use a command substitution to capture the result. Okay, so there is a small, well, there's a performance disadvantage when using a command substitution, right? So whenever you use a command substitution, the function ends up being run in what's called a subshell. So your shell starts a new shell, runs the function, captures the result, and then gets rid of the subshell, which turns out to be inefficient, especially when your function doesn't do very much. And so you have to be aware that there is a performance penalty here, and many bash programmers will discourage you from doing it this way, right? At least for simple tasks like this. Okay, so is there another way to do this? And the answer is yes, but you need to know how bash treats variables when functions are run. And so this is very strange. This is going to be very strange for most of you because you're used to Python and Java. And so bash uses something called dynamic scoping to determine the visibility of variables. Right, so remember in Java, the scope of a variable is the block that it's defined in. Right? That's similar to Python too, but Python has globals as well. Right? Bash is different. So basically the way dynamic scoping works is when a variable gets created, that variable is usable for the rest of the program, including all of the functions that your program calls. Right? So if you put all of your functions at the top of your script, and then in your main script you make a variable A, suddenly that variable A becomes visible to all of the functions in your script, which is weird, right? So with dynamic scoping, visible variables and their values are a result of the sequence of function calls that caused execution to reach the current function, right? And so that means if your script calls a function and inside your function there's a new variable that appears, suddenly that new variable becomes available to the rest of your script. And so you have to be aware that this is an issue when you're writing functions. You can get into all sorts of problems because of this dynamic scoping thing. Right, so what does this all mean? If a script creates a variable A, then it calls a function f. A becomes visible to the called function f, even if f was declared before the body of the script. If f changes the value of A, then whoever called the function gets a changed value of A. Right? And so this is all very weird coming from a language like Python or Java. So here's a function f. Right? It's going to print out the value of A, even though A is not defined yet in this script. Right? So it's going to try to print out the value of A when you call the function. It then sets the value of A on the next line. Right? It then calls the function g. Right? After it calls g, it prints out the value of A, and then it prints out the value of B, which also does not exist yet in the script. But everything's fine because it's bash. Right? What does g do? Well, g simply prints out the value of A, right? Then it sets B. And then it prints out the value of A again. What does the main script do? Well, it sets A, calls F. Sets the value of A, calls F, right? F calls G, right? And so after all of this, it prints out the values of A and B. So what happens here? Okay, so before calling F, A is hello. So that's good. So that line runs, we get hello, right? Now we call F. So we go up to F, right? A is set, so this works just, A is set, so that line works just fine, right? And so A at the beginning of, A at the beginning of F is also hello, right? What does F then do? It changes A, right? So it changes A so that it says F.hello, and then it calls G. So you go to G, right? And G prints out the value of A, which is, not surprisingly, F hello, right? G doesn't change A, so it's also F hello at the end of G, right? Now we go back to F, right? Because F called G, so we go back to F. So what happened to A? Right? Notice that A at the, oh wait, did I print out B? Oh, I'm missing a line. A at the end, no, A at the end of F is F hello. Okay, here we go. Yes, because, because G didn't change A, right? But it did change B. So B becomes G goodbye, right? G didn't change B, it set B here, right? So B doesn't exist at this point in the script until G is called, right? Once B gets set, F can now see the value of B, right? Now at the end of the script, we print out A and B, right? So at the end of the script, A is changed to F hello, and B is changed to G goodbye. Right? And so if that was as clear as mud to you, you can trace through the sequence of events, and the notebook tells you exactly what's happening on each line. Right? So if you need to, if that didn't make sense to you, just follow the steps here in the notebook, and that will explain what's going on. All right. So because of dynamic scoping, you can use dynamic scoping to actually return a value from a function. And there's a couple of ways you can do this, right? So inside the function, you can assign the return values to variables that were visible to the caller, right? So the caller makes up some variables they call the function. At the end of the function sets the variables that they were expecting the caller to define, right? When the function returns, the caller now has the return values sitting in their variables. The other way to do this is your function creates some new variables, assigns the return values to the new variables, and now the caller uses the new variables to access the return values. This is a little bit confusing because when you're looking at the code that calls the function, suddenly a new variable appears, and you have to go back and look at the function to see to see exactly what these values are, or where they came from. Okay, so you can rewrite max2 to use this technique. Right, so max2 is just going to store the largest value in this variable called high. Right? IsInt stays the same. Right? The main script also stays the same. Right? So the main script sets the value of high here. Right? When it calls max2, right, it passes in high, but max2 changes the value of high as well. Right, or can change the value of high. Right, so no matter what happens here at the end of the script, the value of high holds the current maximum value, right, the maximum value of all the command line arguments. Right, and that does in fact work. Right, you get 10 here. Right, so option number 1, main script defines a variable, in this case called high. Right, your function simply reuses that variable to store the result. So this kind of looks like a global variable. Right, high effectively looks like a global variable in this case. Do I show you the other way to do it? Let me just quickly check. No, I don't. So the other option is for max2 to make its own variable up here, right? So I don't know, call it max and max, right? And then down here, after calling max2, you print the value of max down here. Right? That's a little confusing because suddenly this variable max appears, even though it doesn't show up inside the main script anywhere. but they both work. You have to be careful about this dynamic scoping problem. So imagine that you have a function f, it writes a loop, right? So it has a for loop and it uses a loop variable I, right? So for I equals 0 to 10, right? And inside the loop, it calls another function j, right? J also has a loop in it that uses the loop variable I, right? Remember that variable I is shared between the two functions. So when the second function changes the value of I and returns, your for loop in the original function is probably all messed up because it's not expecting its value of I to change, right? The first function is expecting to control its own value of I, right? But because you used a loop variable having the same name inside of another function, that other function can change the value of the loop variable. It's probably not what you want, right? So to restrict the scope of a variable to a single function, and unfortunately to any function called by that function, you can use the local built-in command, right? So this doesn't do what you really want it to do, right? You want local to force the variable to be only local to the function that it's in, right? But it doesn't do that. It forces the variable to be local to that function and any other function that the function calls. So this doesn't quite do what you want, but it helps you in many cases, right? So here's exactly an example of what can happen when you call a function, right? So here the function sets I to 100. Right? I doesn't exist. So if you just look at the script, I doesn't exist until this line of code, right? However, the main body of the script is actually using I as its loop variable, right? And so if you look at this loop, it looks like it should print out it should print out 0 through 9. But it doesn't. It only prints out the 0, right? So first time through the loop, I is 0, so it prints out the 0. Then it calls some function. I gets set to 100, right? Is 100 less than 10? The answer is no, so the loop stops running. And so you end up with this situation here, right? Which is not good, right? You want this loop to run 10 times, but because you set the loop variable up here inside of a function, that screws up the loop. Okay, so what if I make the I in this function local, right? So now this version of I is a new version of I inside some function, right? If some function calls another function, right, and that function uses I, it's going to use this version of I, right? Somewhat confusingly, if the main script calls the other function, the other function gets the main script's version of I, right? So it's all a little bit confusing, but in this case, that solves our original problem, right? Because we declared I to be local here, that I does not affect this I down here. And so that works the way we want it to, right? But remember, that local variable I is visible to any function that some function calls, right? So same example, except some function now calls another function, right? Inside that other function, it can now see the local I that was declared here, right? It doesn't see the I from down here, right? It sees the I that it got from here, right? And so some other function is always 100, right? Our loop here runs just fine, right? But remember down here, if you call some other function, right, the value of I that's seen by some other function now becomes 10, right? So it now sees the I from here and not from here. So you have to be careful about the way that dynamic scoping behaves in Bash. You can get very confusing behavior inside your functions. The loop one is especially hard to find, right? So if there's a loop up here that uses I and there's a loop that here uses I and they call one another, your loops probably aren't going to run the way you want them to run. So be careful with that. All right, so that's functions in Bash. There seems to be something, I think there's something in the loop notebook that I missed as well. Oh yes, C-style loops. I didn't show you these. So jumping back to the loop notebook, if you want a counting style loop, the easiest way to write it is with the for loop and using double round brackets. Right? And so this lets you write a loop that looks like a Java style counting loop. Right? And the Java style counting loop is actually the C style for loop. And so it works basically the same way that the Java for loop works. Right? Here's your variable. This is where you normally declare your loop variable. That's normally a condition involving the loop variable. Right? If it's true, the loop runs. If it's false, the loop doesn't run. And that's normally the update part. So that's where you normally update your loop variable. So a counting style loop in Bash typically looks like this. Right? If you want to, so if you're writing a counting style loop, I think in the last lecture I showed you with a while loop, with an until loop. The for loop is probably easier for most of you to read, right? Given that you've learned Python and Java already. And finally, how do you loop over the command line arguments, right? Well, you know what's, oh, sorry. So star and at are both considered to be parameters that the script can use, and they expand to your positional parameters. Right, so remember, star and at, if you use them as an array index, they expand to the elements of the array. Right? If you just use them on their own, like that, right, you get the command line arguments instead. So if you want to loop over all the command line arguments using a for loop, the standard way of doing it is like that. Right? So for each command line argument in quoted $at, right, the quoting affects $at and $* the same way that quoting affects at and star when you use them as array parameters. Right? So you almost always want to use this form here. Right? You want to quote the $at form. Right? And so that will print out all your command line arguments. And then you can process each command line argument one at a time. Right? And so here, right? So inside the script, notice how you access the command line arguments. It's a bit odd, right? This looks strange, right? Normally, to access a command line argument, you would write $1, $2, $3, and so on and so on and so forth, right? But there's nothing from stopping you from writing $ and then some variable name and accessing the value of a variable using a variable name, right? Or using the value stored in a variable. So here, that $i expands to $1 in this case, right? At the end of the loop, I add 1 to I. So the next time through the loop, that expands to $2, and then $3, and then $4, and so on and so on and so forth, right? So that's a cute Bashism right there, right? And so there you go, right? And so there you get the values of your arguments, right? So first command line argument, arg1, second command line argument has some spaces in it, and then the third one is arg3, which also has some spaces in it. Right? And so that's how you loop over your command line arguments with a for loop. And then I showed you the while loop already using shift, right? So if you want to loop over your command line arguments with shift, right? Shift changes the value of $number, and it also changes the value of all your positional parameters, right? So while the number of command line arguments is greater than 0, right, process your first command line argument, and now shift all your arguments one position to the left, right? That reduces the value of $number by 1, right? So if you started with 4, you now got 3, right? The second command line argument becomes the first command line argument. And so when you print out the first command line argument in this case, you now get the second command line argument. Shift again, number of command line arguments goes down by 1. Third command line argument becomes the first command line argument, and so on and so on and so forth. Right? And so that also works. I'm just going to leave the rest of the notebook. So if you want to know how to read a file one line at a time, the rest of the notebook covers how to do that. Right? I don't think it's important enough to cover this during the lecture. Right? It just uses a while loop and the read command to read the contents of a file. Right? The standard way you do that is with that loop there. All right, so that wraps up the Bash part of the course. I guess any questions about today's lecture content? Yes?
So basically they're all just global variables?
They're not exactly global, right? If they were truly global, then they would be immediately usable anywhere, right? They're not really global. the reason they're called dynamic is because they become visible once you use them, right? Yeah, they're not true globals in that sense.
So would it make sense at the start of a function to set your variables just to make sure there's nothing left over in them from previous runs of the function?
Possibly. It depends what you're trying to do, right? Yeah, it really depends what you're trying to do. Yeah, possibly. Yeah. Any other questions? All right, so I guess on Monday, we're going to switch over to the C part of the course. And what that means for you is that you, if you haven't set up your computer, so if you haven't installed a compiler, if you're on Mac, it doesn't matter. I think you're set up if you follow the instructions. But if you're in Windows and you're using WSL, make sure you have GCC installed so that you can actually compile the C programs starting on Monday. All right, that's it for today. I'll see you next week.